useful properties of continuous functions is their intermediate value property. A function has the intermediate value property if it never takes on two values without taking on every value in between. So this basically just says that if we have a function that is continuous, that it takes on two values without taking on every value in between. So for example, if this is my first value a, this is my second value b, and say this is at -3 and this is 10, then I am guaranteed to get every y value between -3 and 10 between a and b. Some might repeat, but I'm guaranteed to have every single y value at least once. So that brings me to the actual definition of the intermediate value theorem. A continuous function of f on a closed interval from a to b takes on every y value between f of a and f of b. So it's important to note that the closed interval means that we include the endpoints. And f of a is y1 and f of b is y2. So an example of this is if a and b and c are numbers such that a is less than c, which is less than b, just means that c is between a and b, on the interval a to b, and f of x is a continuous function, then there exists a number c, so the number in between a and b, such that f of a is less than f of c, which is less than f of b. This just means that the output of c is in between the outputs of b and a. So what makes this a little more clear is if we look at a graph. So on this graph, you're going to want to have that a is the smallest value, so this is your smallest x value, and b is your largest x value, and you're going to pick some c that's in between a and b. So as long as f of b is larger than f of a, we're going to guarantee that we're going to get every y value in between. So if I pick some random point c and follow it up the graph, I get that this value here, which is f of c, is in between f of a and f of b. So example 5. We're going to use the intermediate value theorem to determine if there is any real number exactly one less than its cube. So is there any real number that's exactly one less than its cube? So we need to write that in an equation first, and yes, we're back to word problems. So any real number, x, so this is going to be our real number, which is equal to 1 less than its cube. So 1 less than its own cube. Okay, so now here we're going to set up an equation, and we're going to go 0 is equal to x cubed minus x minus 1. I did that just by subtracting x from both sides. And here's the kicker. We're going to let x be any real number, so we're trying to solve for it. And so here we can draw a conclusion. So since polynomials are continuous and the domain is all real numbers, then by the intermediate value theorem, there must exist a y value on its range, which is from -infinity to infinity. So basically we've set up an equation and we even guaranteed that there will be an answer because the intermediate value theorem tells us that there has to be an output. Now for the hard part, solving. So we're going to find it, however we're going to use our calculator to do it. So here's a set of instructions that you might want to copy down, and then I'm going to show you how to do it on your calculator. Alright, so on our calculator, we just turn it on, and we're going to graph y1, which is equal to x cubed minus x minus 1, and then we hit graph, and your window might look messed up. Mine's okay, but I'm going to show you how to make it normal if it is messed up. You push zoom, and then 6. So the standard window. And what that's going to do is it's going to make it a 10 by 10 grid. In this case, it didn't change mine, but if yours was messed up from the previous problem, it might change. So what I want to do is solve this equation. And since I set it equal to 0, to solve it, I find the x-intercept. So unfortunately, I can see it. It's somewhere around right there. However, I need to zoom in. So I push zoom in, and then I'm going to push zoom in right there. And this is going to make it much easier for me to see that intercept. So now I need to calculate the 0. So to do that, I push second, calculate, and then I'm going to calculate the 0. I pick a left bound. So the left bound needs to be on the left side of the 0. So I pick here. And then you need to be on the right side. So I'm going to pick somewhere over here. And then you make a guess. I'm going to guess it's somewhere around, say, here. And I push enter. So now I have my 0, which is 1.324718 approximately. And so in calculus, we're going to truncate. So we're going to go 3 decimal places and then stop. So based off of our graph, we got that x is about 1.324718. And so by truncating, we're going to say x is about 1.324. Again, truncate means you go 3 decimal places and then stop. So if we look at the graph, we can see that the x-intercept is right there. And now if we want to check our answer just to make sure we were right, we have that the number itself is equal to 1 less than its cube. And if you put this in a calculator, you will get that this does check out.